Hello everyone. So today let us read about limitations of crystal field. Okay. So without wasting time, I'm waiting for 2 minutes so that everyone can join. And I don't know what's happening. Yes. Okay. Can you see me? Can you see me, guys? Let's start without wasting time, and I will revise some questions of coordination compounds in my copy. How beautiful I have decorated. Can you see this one? Yeah. So we'll start now only with this is the revision one. Okay. So for NEET 2026, I'm preparing for NEET 2026. I'm a NEET aspirant, and I'm going to revise limitations of crystal field theory. Then I will read about means we, because we are in the light. So without wasting time, let's start with the limitations of crystal field. Then our next topic will be homolytic carbonyl compounds, and these are very important. So keep your copy with you also, because if you are going to revise it, and if you don't write it, you forget everything. So so start with the limitations of crystal field. So what is crystal field? Okay, so there are many limitations. So without wasting time, let's start. The crystal field model successfully explains which property of quotation compounds. So there are many properties, and there are four properties. What are they? The formations, the structure, the color, and the magnetic property. Okay, so crystal field, what are the limitations of crystal field? The limitations of crystal field are: first one is the crystal field model successfully explain which property of quotation compound. Okay, so the formation of crystal, the formation. Second one is the structure. Third one is the color. Fourth one is the magnetic property. Crystal field model indicates the point. The ligand should be a point charge. Okay, the crystal field model indicates that ligand should be a point charge, and as a result, the anionic ligands. So what are the anionic ligands? The anionic ligands are iodine, fluorine, chlorine. Okay, should exert the greatest splitting effect. So what is the anionic ligand? The anionic ligand actually are found at the lower end. The anionic ligands are found at the lower limits. So what is the meaning of lower end? The lower end means the left side. Okay, the left side of the spectrochemical series. It is written in the NCERT only, and it's very difficult to understand the meaning of lower end, but the lower end means that in the left side. So the anionic ligands are found at the left side of the spectrochemical series. Anionic ligands do not Anionic ligand does not take into account the covalent character of bonding between metal and ligand. So the anionic ligand does not take into the account the covalent characters of bonding metal and ligand. So metal and ligand showing the, if a metal and ligand showing the covalent bond, it will deals with the sharing of electrons. So covalent bond deals with the sharing of electrons. Covalent bonds is equal to sharing of electrons, and it's share the electrons between the metals and ligand. Okay, and sharing is possible between the metal and ligands in the covalent bond. So how a bond form? A bond form between metals and ligand. And so how a bond form? Actually a bond form by with the help of two unpaired electron, and when the bond form between two unpaired electron, it will form a single bond. So when a single bond will form, it will obviously give a one sigma bond. So if the bond is double, there will be one sigma and one pi. If the bond is triple, there will be one sigma and two pi bond. So consider an example nitrogen and its atomic so consider example nitrogen and its atomic number is 7. So if we write the electronic configuration, the electronic configuration will be 1s2, 2s2, 2p3, and 1s2, and the like 1s2 is written in the upper side, so that indicates the orbital's electron. Okay, that indicates the orbital's electron. And the quantum number like 1 is 2 written, so 1 is the quantum number, like 1 is the quantum number, like 2 is 2, 2 is the quantum number, 2p3, so 2 is the quantum number, so it's like that. And consider there is s orbital, so in a s orbital there will be 2 electrons. For p orbitals there will be 6 electron. For d orbitals there will be 10 electron. Okay, so a formula can be written that if we find that orbitals p, so there are 5. I think this one everyone know. So the main thing is that how a bond form between two unpaired electron. Yes, a bond form between two unpaired electron. And when two unpaired electrons are connected, means when two unpaired electrons are connected by a line. Okay, so it will form a bond, and that bond will be the sigma bond. If there is one bond, there will be one sigma bond. And we have to take the last electron only, last electrons orbitals only. And anionic ligands are some of the weakness of CFT, and CFT full form is crystal field theory, which are explained by the ligand field theory, and ligand field theory can be written as LFT, and the molecular orbital theory, that is MOT. Wait, hi, hello. So bonding in metal. So here the metal will be the transition metal. Okay, and the bonding should be in double bond, and metal should be in transition metal. So that is indicate the 3D series. That indicates the 3D series. And carbonyl compounds. So a carbonyl compound should contain carbon and oxygen, and they should connect it with the double bond. Okay. So a double bond will found between the carbon and oxygen. Now let's come to the homoleptic complex and heteroleptic complex. Those coordination compounds which contains one type of ligand. Okay, one type of ligand, not the number. Consider PTCl4. So ligand will be the chlorine. So CTCl4, Cl4 will be the ligand. So the ligand is 4 in number, but you cannot say that it is heteroleptic complex, because its ligand type is 1. So you should consider the ligand type. So PTCl4 2 minus. So PT is the metal, and Cl is the Cl4. So this mistake I have done when my teacher taught. When my teacher was teaching yesterday. Yes, yesterday no, before I think the day, I've forgotten the day. Okay, sorry for that. So when my teacher is teaching, I have done the similar mistake that though the Cl4 is 4 in number, I've said yes, it's a heteroleptic complex or like that. So my teacher scolded me, and that is me only who have made the mistake, but he cannot identify the person who had done the mistake. Wait for a minute. Different type, it should be more than one. So for example, PTNH3 whole twice and Cl2. So the ligands are NH3 and Cl2. So the ligands are two type, right? So it is known as the heteroleptic complex, and the metal is platinum. Okay. So which are strong field ligand and which are weak field ligand? The strong field ligands are carbonyl NONH3, and the weak field ligands are fluorine, chlorine, bromine. Means all the halogens are the weak field ligand, and water will be the weak field ligand. Now for metal, which are considered as metal, means I am talking about the transition metals. Here all are transition metal. So the transitions metal examples are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Okay. Now what's their atomic number? For scandium, atomic number is 21. For titanium, the atomic number is 22. For vanadium, atomic number is 23. For chromium, atomic number is 24. For manganese, atomic number is 25. For iron, atomic number is 26. So only like this it will go. So what is tetrahedral complex and what is octahedral complex? Whose ligand number is 4, it will be the tetrahedral complex, and whose ligand will be the number 6. Whose ligand number is 6 means whose coordination number is 6. It will be the octahedral complex. So for example, PTCl4. So here the ligand is 4 in number. Okay, so the structure will be the tetrahedral complex, and whose ligand number is 6. Ligand number is 6 means whose ligand are 6 in number. It will be the octahedral complex. For example, MnCN6 2 minus. So its structure will be the octahedral, and and its ligand is Cn, and its metal will be Mn. Jai Hind. Jai Hind. Homoleptic carbonyl compounds. So only homoleptic carbonyl compounds. Homo means what? One type. So homoleptic carbonyl compounds. Homoleptic carbonyl compounds. Only carbonyl compounds means C double bond O. Carbonyl compound should contain carbon and oxygen, and it is connected with the double bond. So C double bond O will be the carbonyl compounds. Okay, and homoleptic compounds are formed by the most of the transition metal. The carbonyl compounds have simple and well defined structure, and only one type of carbonyl ligands will be present here. Okay, so for homoleptic complex, what are the conditions of homoleptic complex? The conditions of homoleptic complex are only carbonyl ligands will present. Homoleptic carbonyl compounds formed by the most of the transition metals. Okay, homoleptic carbonyl complex will be formed by the most of the transition metals, and these carbonyl compounds will have simple and well defined structure, and only one type of carbonyl ligand will present here, and carbonyl compound CO will be strong field ligand. What are the strong field ligand? The strong field ligands are carbon, NOs, NH3 and so on, but the weak field ligands, all halogens and the water will be the weak field ligands. So homoleptic carbonyl compounds examples are, the homoleptic carbonyl compounds examples are hetero means tetracarbonyl nickel, tetracarbonyl nickel. So tetra means 4, carbonyls means CO. So tetracarbonyl nickel, nickel will be Ni. So what is the oxidation number of tetracarbonyl compounds? The oxidation number of tetracarbonyl nickel. So the oxidation number of tetracarbonyl nickel will be 0. You can find the oxidation number with the help of X. Like for nickel, you can consider nickel as X, and for carbonyl compounds, the charge will be the yes, 4 into 0. So it is a compound C double bond O. It will be it's a compound, so it will be the 4 into 0 equal to 0. This X plus 0 equal to 0. So X will equal to 0. So oxidation number of NiCO4 will be 0. Right? So oxidation number will be 0. So what is the structure of tetracarbonyl nickel? So I have already said, for whose ligand number is 4, the structure will be the tetrahedral. The structure will be tetrahedral. So pentacarbonyl iron, for pentacarbonyl iron FeCO5. So penta means 5, right? So pentacarbonyl, so carbonyl should be 5. So carbonyl should be 5, and what is the structure of carbonyl? C double bond O, right? C double bond O will be the carbonyl structure. Pentacarbonyl iron, and iron is written as its abbreviation is Fe. So FeCO5. So its oxidation number is 0. Okay, its oxidation number is 0, and its structure will be the trigonal bipyramidal, and its structure will be the trigonal bipyramidal heterocarbonyl communion. So this so you can write like CrCO6. So when the ligand is 6, its structure will be octahedral. X plus 6 into 0 equal to 0. So it will be the octahedral. And decacarbonyl dimanganese Mn2CO10. So its oxidation number will be 0, and its shape will be the, see its shape, you can write like this. It is made up of square 2 pyramidal. So units joins by Mn and Mn. Here bridge bond is found. Here bridge bond equal to 0. No, here bridge bond is not found. Here bridge bond equal to 0. For the decacarbonyl manganese, the bridge bond is 0. So no bridge bond is formed here. So octacarbonyl dicobalt, its oxidation number is also 0, and it has CO bond bridge. So for decacarbonyl compounds, there is no bridge bond, not bond bridge. Okay, for decacarbonyl compound there is no bridge bond, and for octacarbonyl dicobalt, it will form a bond. It has CO bond bridge and 2 cobalt metal. Here bridge bond is present, but decacarbonyl manganese has no bridge bond, and octacarbonyl dicobalt has a bridge bond. Here number of bridge bond is 2. Here number of bridge bond is 2. For octacarbonyl dicobalt, bridge bond is 2. For decacarbonyl manganese, there is no bridge bond. But for the octacarbonyl dicobalt, for octacarbonyl dicobalt, the bridge bond is 2. For decacarbonyl manganese, there is no bridge bond. So it is very important, and it is made up of square 2 pyramidal. What is made up of square 2 pyramidal? Decacarbonyl manganese made up of decacarbonyl manganese made up of square 2 bipyramidal. Okay, and the octacarbonyl dicobalt has 2 bridge bond. So what is mononuclear? Nuclear here means metal. Consider nuclear means metal. So when one metal is connected with one type of ligand, it is known as mononuclear. What is dinuclear? When two metal is connected with the one type of ligand, that is known as dinuclear. What is trinuclear? When 3 metal is connected with one type of ligand, that is trinuclear. What is tetranuclear? Tetra means 4. So when 4 metal connected with the one type of ligand, that is tetranuclear. Now come to the organometallic compound. So what is organometallic compounds? So split the words. So organo comes from organic. So organic deals with the carbon. Obviously there will be carbon. And metals, here metal will be the transition metal, and the compounds in which transition metal is directly bonded with the carbon, that is known as the organometallic compounds. So what are the types of organometallic compounds? There are two types of organometallic compounds. First one is the ionic organic organometallic compounds, and second one is the covalent organometallic compounds. So for the ionic organometallic compounds, what is ionic? Ionic means ions. So ions are of two types. One is cation and second one is the anion. And cation means the positive charge. Positive charge means the deficiency of electrons, and deficiency of electron deficiency means what? Losing of electrons. And what is anions? Anion means anion sign is negative, and negative sign indicates that there will be gain of electron, and when there will be gain of electron, their mass also increase, and when there will be deficiency of electron, their mass will also decrease. Okay. A charge cannot exist without mass, but mass can exist without a charge, because we can find a neutral body, but a charge cannot exist without mass. Ionic bond is present between the metals and cobalt. Ionic bond is present between the metals and ligand. For example, for example, R Li plus. Okay, R minus Li plus. So you can find cations and anions. So you can consider this as a ionic organometallic compounds. Okay, and what is covalent organometallic compounds? As we have already read, covalent means what? Covalent means the sharing of electron. So covalent bond means the sharing of electrons. Covalent bonds are found between the metals and the carbon, and the covalent bonds are of three types. First one is the sigma bond, second one is the pi bond, and third one is the sigma and pi bond. And let's come with the sigma bonded. Sigma bond is a single bond, right? Sigma bond is a single bond, and the bond is formed between two unpaired electrons, and it forms a single bond. Sigma bond is present between a metal and a ligand. For example, tetramethyl. Tetra means 4, methyl means R group, right? Tetramethyl teen symbol is SN. And what is the structure of it? The structure will be the tetrahedral. When there will be 4 ligand, obviously the structure will be the tetrahedral. And RMgX is a Grignard reagent, and it's the organic reagent. So RMgX. So what is the sigma? How many sigma bonds can be found in RMgX? And you have to find the sigma bonds between the carbon and metal. So the sigma bonds are 5 sigma bond here. For Grignard reagent, if you want to find out the sigma bond between the carbon and metals, there are 5 sigma bond. Okay. And for example, for metals like Al2Me6, for Al2 aluminium is a metal, and it is connected. There are 2 metals here, and Me means methyl group, so there are 6 methyl group. Can you find out the sigma bond here? Obviously there are 8 sigma bond. If he means the common mistake I have done with the I have write down the 9 sigma bond, but there will be no 9 sigma bond, because we have to find the sigma bond between the carbon and metals. So I have calculated the sigma bond between the metals and metals, so it is my wrong concept. So you have to find out the sigma bond for the metals and the carbon. So for Al2Me6, the sigma bond will be 6. So what is pi bond? So pi bond is denoted by double bond, or it can be triple bond. A single bond doesn't have any pi bond. So sigma bond, for double bond there will be 1 sigma bond and 1 pi bond. For single for double bond there will be 1 sigma bond and 1 pi bond. And for triple bond there will be 1 sigma bond and 2 pi bond. For single bond there will be 1 sigma bond and 0 pi bond. For example, ferrocene, Fe into the 5 C5H2. Fe into the 5 C5H2 is the formula of ferrocene, and ferrocene formula is Fe into the 5 C5H2. Fe into the 5 C5H2. and whole twice 2. So the common mistake I have done, I have thought that ferrocene formula there will be diferrocene, right? Because into the 5 C2H5, so in whole twice, so there will be diferrocene. So it's my common mistake. So the ferrocene formula is only Fe into the 5 C5H2. So F is the metal and N is the number of carbon in ring, and there will be a ligand linear chain. So N is the number of carbon in ring and linear chain, and its hapticity is 5. Okay, and for dichromium, for dibenzene chromium, dibenzene means there are two benzene. So dibenzene chromium, Cr to the power 5 C6H6. So the hapticity will be 6. And for this salt, what is the formula of this salt? KPtCl3 into C2H4. So the hapticity will be 2. And up to, and there are another one, that is the sigma and pi bond. It occurs between the metal and carbon. So examples, NiCO4 sp3, so it will be tetrahedral, and MnCO5 dsp3, and its structure will be the trigonal bipyramidal, and FeCO5 dsp3, and its structure will be the trigonal bipyramidal. In short, you can say TBT. And AcrCO6, its structure CO6. So ligand is 4. Ligand is 6. So the structure will be the octahedral, and its hybridization will be the D2sp3, and MnCO10, Mn2CO10, and its ligand is 10. So it will be the trigonal bipyramidal. Ligand is not 10. Ligand is Mn2CO10. So it can be written as MnCO5. So its ligand is 5, and its structure will be the trigonal bipyramidal. And for CO2, CO8, so its structure will be the 2 tetrahedral unit. So up to this I have revised the chemistry. Now my target is to is to revise physics. So come to the physics class to revise with me. I'm revising just what my teacher is teaching. I'm revising that only. So thank you for joining.